Have you ever wondered how the mirror can detect movement in a video or track the motion of objects? It's all thanks to a concept called optical flow.
So what is optical flow? Optical flow is the pattern of apparent motion of objects, surfaces, and edges in a visual scene. It can be shown in these two diagrams. Optical flow is caused by the relative motion between the observer or camera and the scene. To better understand optical flow, let's imagine a moving object in a video. As the object moves, the brightness pattern of its pixels changes, and the camera records this change as motion. The camera then analyzes the brightness patterns of pixels over time and calculates the direction and speed of motion at each pixel. This information is represented by a vector field that describes the motion of each pixel or region in an image over time. The vectors show the direction of motion, while the length of the vectors shows the magnitude or speed of motion. Optical flow has many real-world applications, including object tracking, motion detection, and video stabilization. Here is one of the examples of games for such application. Is the Child of Eden. This game uses the player's movements to control the flow of light and sound in a futuristic world. The player can shoot at on-screen objects by pointing and moving their hands. Moving on, we have an optical flow dance party. We'll use optical flow to track the movement of people dancing and create visual effects or animations based on their motion. Despite its usefulness, optical flow has some limitations. It assumes that the brightness of pixels remains constant between frames, which is not always the case. It also struggles with occlusions, where objects in the scene are partially or fully obscured. Researchers are working to improve optical flow by developing algorithms that are more robust to changes in brightness and occlusions. They are also exploring the use of deep learning to improve the accuracy of optical flow calculations. Before we wrap up this topic, here's a joke for you. Why did the optical flow algorithm feel sad? Because it was always tracking negative movements. So let's move on, shall we? Welcome to Action Recognition Using a Camera, where we show you how computers can learn to see and understand human movements. In this video, we're going to take you through the process of how computers can recognize different actions and movements using just a camera. Action recognition is a type of artificial intelligence that allows computers to understand and interpret human movements. By analyzing video footage captured by a camera, computers can learn to recognize different actions and movements and assign them labels, such as walking, running, or jumping.
Action recognition works by breaking down video footage into individual frames and analyzing the changes between frames. By tracking the movement of specific points on the human body, such as joints and limbs, computers can learn to recognize different actions and movements.
Action recognition can be used in many real-world applications, such as in sports analysis tools or in gaming and virtual reality simulations. But here, we're going to use it to make you feel like a superhero. Now it's your turn to become an action hero. Just put on your superhero costume, perform your favorite moves in front of the camera, and watch as the machine learning algorithms recognize and label your superhuman abilities.
While action recognition technology has come a long way, there are still some current drawbacks. For example, action recognition can struggle with recognizing actions that are similar but have slight variations, such as different types of jumps or kicks. Additionally, low-quality video footage or complex backgrounds can make it difficult for computers to accurately analyze the movements. Looking to the future, we're exploring ways to improve action recognition technology, such as incorporating machine learning and deep learning algorithms to enhance accuracy and efficiency. We're also exploring new applications for action recognition, such as in virtual reality or robotics.